Without further ado, let's talk about percents. So this lecture is going to talk about converting decimals to percents, percents to fractions, and then we'll apply this with what the book calls the portion formula, base rate, portion, stuff like that. And then basically, if you have two of the numbers, it's solving for the unknown. So if you think about last class when we were trying to figure out what solving equations, solving for x, it's kind of like taking what we learned in the last chapter in chapter 5 and applying it to a specific relationship with percentages. So this isn't the numbers that we had when we did this experiment, because notice how there's only 55 M&Ms, and I think we had 105 M&Ms in our box. I've got a box right here. I was tempted to open it up and do it again, but I didn't want to waste the M&Ms. I figured I should eat my dessert after dinner, not before dinner. So this week I won't use them, but they're here for the future. I'm sure they'll come up again. If there's M&Ms on the cover of your textbook, I'm sure they're going to try and use it in every which way. So anyways, I don't know why it says what colors come in your bag. That sounds strange, but yeah, so there was 55 in each or in this bag, and the distribution was that there was 18 yellow, 10 red. I don't know why this is green, but 9 blue, 7 orange, 6 brown, and 5 green. And so if we have fractions here, can we simplify these? That one can simplify to 1 over 11. That one can simplify to 2 over 11. This can simplify. I don't think so. I don't think so. I don't think so. And I don't think so. But anyways, when we converted this to decimals to the hundredths, we determined that this was 0.3273. So we got rounded it to 0.33. We got, let's pull this back up. We got 10 over 55, which is 0.1818. Then we got 9 over 55, which was 0.1636, then 0.1273, then 0.1091, and then we got 0.0909. So if we're going to convert this to percentages, then what we're going to do is we just need to, let's look at this word for a second. Percent. So when you think of the word percent, it's supposed to mean per 100. So cent as in like century, a century is 100 years, not per like penny. But why is a penny called a cent? Because it's 1/100th of a dollar. So it's the 100th of a dollar. So that's why cents are called cents. It's not a made up word. It has a root in numerical reasoning. So whenever you're finding a percent of something, you're basically finding per 100. So if we have, here we kind of like simplified it a little much. This is kind of the to 4 significant digits relationship. If you're going to convert a decimal value, if it's less than 1, into a percentage, then what you're going to do is you're going to multiply by 100. That's what this cent is telling you, is you're multiplying by 100 to get it as a ratio per 100. So like for every 100 M&Ms you pull out, how many of them would be yellow? For every 100 M&Ms you pull out, how many would be red? What portion of it? What percentage of it? So when you do that, remember, based on our little table that we had when we did the decimal lecture in chapter 3, we had basically in the middle, we had 1, and then we had tens, and then we had hundreds, but then we had the decimal point, and then we had 1/10 and 1/100. So if your decimal point is 2 digits to the right, that means that you're in hundredths. So that means in order to get it in percentage and multiply by 100, if you go 1, 2, then you end up having you're converting it to a percentage. So so notice how we're here and we want to get to 1, so we want to move it 1, 2, so we move it 1, 2, and then you end up with approximately 33%. And then if you actually calculated this out, originally it was 0.3273. So if you want to round the percent to 100th, you would go 1, 2, and you'd leave 2 digits on the other side, which is why you get 32.73%. And then here, if you have 0.1818, you move it over 1, 2 to multiply by 100, and then you round it to the nearest hundredth. So that's why you get the 18 on the other side. 0.1636, move it over 1, 2. So that gives you 16.36%. 0.1273, 1, 2, that gives you 12.73%. 0.1091, 1, 2 gives you 10.91%. And then this one, you actually 0.0909, 2, you end up with 9.09%. Then I'll add all these up, you get 100%. Interestingly enough, according to this infographic, it turns out that most often the distribution is as follows, that 20% are green, 20% are orange, 30% are blue, 10% are red, 10% are yellow, and 10% are brown. So one of these, if we compare what we have, so let me clear the ink on this because it's a little messy right now. If we compare these, are any of these numbers close to what this research found? We're half as many. We were at 9% and they had 20%. So this is off by about 11%. 20 minus, oh wait, orange. So 20 minus 12.73. So we're about 8. We're about 7.27% off. Less than. Brown, we're actually pretty close. We're over by 1%. Blue says 30%, 16.36. So we're actually under by 13.67%. Red, we're actually over by 8.18%. And yellow, we are way, way, way over by 22.73% based on what their survey came out with. So when we get to the end of the course and we talk about statistics and percentages and things like that, well, we can actually, maybe I'll have you all get your own little box of M&Ms. We'll count them all together and then see how much deviation we get from this estimate. Because in any given box, you could be all over the place because it's one sample. And sometimes there's outliers. So in this case, according to the averages, we should only have 10% yellow in the box. But in this case, we have a third of yellow in the box. So how do we convert decimals to percents? As I mentioned before, if you have 0.3, remember it's hundreds. So you go over 1, 2. And then if you're going from 8 to a whole number, you go over 1, 2, you get 800%. 0.007, you go over 1, 2, and then you're at 0.7%. So you're always moving the decimal place 2 places to the right when you're multiplying by 100, because that's what percent means. In this case, we didn't need to add any zeros. In this case, we did because we had a whole number. And so this is true. So even if we had like 1.3, we would go over 1, 2, and it would be 130%. So always, 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 you first move over 2 decimal places. Whoops. And then you add the percent sign. That's all. That's all you got to do when you convert a decimal to a percent. Now, what if you're rounding? So we had 18 over 55. I think that was the yellow M&Ms. I think we got 0.3273, if memory serves me correctly. Yes. And so if we want to convert decimals to percent here, then we are going to move over 2 decimal places and we get 32.73%. Now, if I wanted you to round this to hundredths, do we have to do anything? Or are we done? No, we're done. Because if we remember, tens, ones, tenths, hundredths. So we're done. If I wanted to round this to tenths, what would I round it to? Would I round it to 33? Would I round it to 32.7, 32.8? What would I do? Can drop in the chat, 32.7. Agree. Cool. Yeah, so we would chop off this and we would just have 32.7. We would round down because 3 is less than 5. If I wanted to round this to a whole percentage, what would I round it to? 32 or 33? Yeah, I would round it up to 33% because it's greater than 0.5. So I guess I could have just erased the whole ink. It would have been easier. So this was 32.72727 repeating. So if you want to move it to hundredths, in this case, we had this long digit. You could have even called it 0.327 repeating. You know what that bar means? That bar means that anything under it is repeating. So like pi doesn't have a bar above it because the digits don't repeat in the same order. If you did 1/3 and you converted it to a decimal, you could technically do that. You could actually go point, and in 2/3 you could do 2/3. You could technically go as simple as that, but most people round to hundredths. So you would go like 0.66 repeating and 0.33 repeating. In this case, remember it's the bar is only above the 27 because the 3 doesn't repeat. It's the 27 that repeats after it. So that's why. So this really means 0.3272727 . So that bar just means those numbers underneath it repeat themselves into perpetuity. So in this case, we were rounding to hundredths. We determined that if we rounded to tenths, we would round down because it's less than 5. If we were going to round to the next whole percentage, we'd round up to 0.33 because the tenths digit was above a 5. We could have went to thousands and then it would have been 0.3273 because we would round up because the 7 was higher than 5. So if you're going to thousands, it would be 32.72. Or yeah. So whoops. We had to convert to percentage, but if we were rounding up, we would do 0.727. We'd round down actually because this is below 2. And so you can keep doing that on and on and on. When I was in physics, long time ago, high school physics, we spent a lot of time talking about significant digits. I'm not a big obsessor over significant digits. We don't live in a world anymore where like adding extra digits is going to be problematic because we don't have a strong enough computer to hold all those digits anymore. Back in the day when you only had like a solar calculator's worth of energy powering your entire computer, you had to cut corners at certain points for saving data and saving energy and saving processing power, but now we're not in that age anymore, so significant digits aren't as big of a deal to me. On the homeworks, I do put hundredths typically. Mainly the reason why we do hundredths is because dollars and cents tend to be hundredths. So if you get like, I don't know, $172, 172.1956, you would just go to 0.19. Oh, it's 5, so I'd round up to 0.20, and that's the pennies in the instead of the dollars. Dollars are on the left-hand side, cents on the right-hand side. So again, most of your problems will be hundredths, but I do typically try to put a buffer in that allows for you to like round up or down and it'll still capture it properly if you decide to go to like thousands or millions or whatever. Recommend not I would, unless you're buying Bitcoin, I would recommend not having to worry about millions of whole. So we're used to cents and being in hundredths, even though at the gas stations it's thousands because they round up that 9/10 of a cent to try and get an extra penny out of you per gallon. But if you're buying something like a cryptocurrency where it's super divisible, a millionth of a Bitcoin matters. Or if you're buying like some cryptocurrency that has like hardly any value, then you could buy like 10 million of one of them and it's like $1. Like, so those little infinitesimals do matter when it comes to certain things, but if we're living in a world where we're only divisible by 100, then it's not as big of a deal. So if we want to convert percentages to decimals, we go in the opposite direction. It should make sense because if we're going from decimals to percent, it's times 100. If we're going from percent to decimals, it's dividing by 100. So we're always just going to move 2 places in one direction or the other. So if you're trying to convert like 33%, so if you're like, oh, this clothing item is 33% off. When you're trying to do the math problem in your calculator to determine what the actual price is, then without going to the price scanner, you need to convert this back to a decimal, because if you were to multiply the original price by 33, you would get a very large number. So you need to make sure that you're converting this to a decimal. So this would just be 0.33. Percentages are whole numbers, but they're really expressing a decimal to the hundredths value, but as a whole number. That's really all they are. So if you're converting from a decimal to a percent, you're multiplying by 100. Since we know that we're in base 10, we move over 2 digits, 2 decimal places if we're going that way. And if we're converting back from percents to decimals, we're dividing by 100 because we're getting back to the actual number or the actual proportion. So if you had 0.4%, then you would add 2 zeros and the dot, which is why you end up with 0.04. If you convert from 54.5%, then you go over 2 and you end up at 0.545. This intermediary step is just getting rid of the percentage sign. But the real magic is moving over 2 decimal places to the left. And then if you have 824.4%, move over to the left, and then you're left with 8.244. When we learn about interest in chapter, I think it's chapter 10 or chapter 11, converting from a percentage to a decimal is going to be quite critical, because let's say that you're investing in a stock and you want 7% returns. When we plug in 7% into our interest equation, we're not going to express it as a whole number, because 7 in a decimal form really means 7x, not 7%. So we need to remember to convert back to a decimal value. So if 7% is the return you're getting on your interest, well, we have 7 move over, and it's 0.07 that you would plug into the equation. 7% will still give you a big number over an extended period of time when you plug it into the PERT equation. A whole number of 7 will give you a calculator breaking number. Because the way the interest is calculated, it's the number of years times the interest rate as an exponent. So when you like square something, you multiply it by itself. So if you had like $1,000 and you squared it, that would be a lot of money. 1,000 times 1,000 is $1 million. So let's say you put $1,000 in the bank and you plugged in 0.07 times 30 years. That would still give you a substantial number to which your money is growing by. But if you multiply 7 times 30, that means it's 210. So imagine putting 1,000 to the 210th power. That would be a very, very large number. In fact, there's probably fewer atoms in the universe than whatever dollar amount you calculated with that formula. So it's important to remember that when you're converting a percentage to a decimal, you need to divide by 100, and that moves you over 2 decimal places to the left. And if you're trying to convert from a decimal to a percent, you're multiplying times 100, and you're adding 2 decimal places to the right from where you're originally at. So if we're going to convert fractional percents to decimals, what we have to do is we have to convert the decimal to the fraction to a decimal. Then we convert the decimal into another decimal, but we have to remember where we're going. So if you have 1/4%, you first need to convert this fraction to a decimal. So you can do this a number of ways. I would hope that you would know that 1/4 is 0.25. But if you didn't, then you have to do the long division process. Well, borrow the 10 point, and then 2 times 4 is 8, 2, 0, 5, 20, 0. And there's your answer. But that's not the entirety of the answer because that's still a percentage. So if you have 1/4 of a percent, which is a really small number, you have 0.25%. You still have to convert it back to a decimal, so you have to add 2 decimal places to the left, and you're left with 0.0025. If you want to convert a mixed number, you need to take the wholes and turn it in and add it to the numerator. So if you have 7 3/4%, you need to multiply this whole number times the denominator to get 7 times 4, which is 28. Add that to the 3, gives you 31. So you have 31/4. So you percent, don't forget it's still a percent. So you can do the long division process and get, okay, 31, 7, 28, 3, 0, 7 again, 28, 2, 0, 5. And you now have 7.75%. Go over 2 places, and you have 0.0775 is your final answer. Trying to erase this so it's not. So again, step 1 is to convert this into the fraction into a decimal, but a decimal percentage. If you have a mixed number, then you need to multiply the whole number times the denominator, add that to the numerator, do your division process. And then once you're done with that, to convert it from a percentage to a decimal percent to a decimal, you need to drop the percent sign and move 2 decimal places to the left. Any questions so far? So if we want to convert fractions to percents, well, if we have 3/4, we need to convert that to a decimal. Hopefully you would be comfortable with that. Just some of these rule of thumbs, but if you want to do the process, you have 3/4, 0.028 from a 7, 2, 0, 5 times 4, 20 cancels out. So you're left with 0.75. That's what we got here. If you want to convert this to a percentage, what do? We add, or excuse me, not add, we move the decimal place to the right. So decimal to percent over to the right times 100. If we're going from percent to decimal, we're dividing by 100. So if we're going D to P, we're multiplying times 100. If we're going from P to D, we're dividing by 100. So if we want to do this, we can go over twice, get 75%. If we have 1/5, 10/5, 0.2, 10, 0. So we have 0.20 or 0.2. Doesn't matter, we'll still find the answer. 0.2, go over twice, and we have 20%. So real quick, let's practice this. If we have 7/9, convert 7/9 to a percentage, round it to the nearest hundredth. So I'll type that in the chat. Convert 7/9 to a percentage, rounded to the nearest hundredth. Without your phone calculator, even though I'm doing that exact process. And remember that nearest hundredth as a percentage is different than nearest hundredth as a decimal. So I'll start going through the work here while you're going through your work. So if we have 7 divided by 9, we need to go to 0.9 times 7 is 63. So that's the highest number. Get 7. 9 times 7 is 63. 7. Looks like we're going to get 7s all the way through. So if we have 0.7777, we need to convert this to a percentage. So we need to move this 2 spaces to the right. So we get 77.77. If we have a 7 again, then that rounds up. So this becomes 77.78%. If we want to convert a whole percentage or a fractional percent to a fraction, so if we have 156% and we want to convert this to a fraction, we're going to go 156, take off the percentage, and then divide by 100. So we're left with 156 over 100. If we want to simplify this down, we can divide by 2. So we end up with, well, I think we could divide by 4, but we'll start with 2. So 156 divided by 2 is 78 over 50. Divide by 2 again, you get 39 divided by 25. I don't think that's divisible anymore. If you want to, so that would be an improper fraction. If you want to convert this to a mixed number, then you would subtract 25 and they would be left with 1 and 14 over 25. So simple. So basically when you're converting a percentage into a fraction, really, it's just, remember, if you're dividing by 100 to go from a from a percentage to a decimal, it would make sense that if you're going to go to a fraction instead of a decimal, it's the same process. So you would just put 100 underneath and then simplify. Any questions there? Oh, here's an extra version. So if you wanted to do 1/8 of a percent, you would do 1/800. And there's no simplification there because you can't divide 801 by anything. One's just the top. Since you have 1 as the numerator, you're never going to simplify that beyond whatever it is. So if you have 1/8 of a percent, it's 1/8 times 1/100. So you get 1/800. If you want to convert a mixed number to a fraction, it's going to be a mixed decimal percent. So in this case, we have a 12.5%. And you want to convert this to a percentage. Again, since it's a mixed number, multiply this times the denominator. So you get 24 plus 1/2. So it's 25/2. Since you're converting it to a fraction, you still need to divide the denominator by 100, which is the same as multiplying it times 1/100. So you end up with 25 divided by 200. This is simplified by 5. Actually, it's simplified by 25. You can divide both sides by 25 and you should get 1/8. If you had 12.5% and you wanted to convert this to a fraction, there's a couple of ways that you could do it. You could just add the extra step and convert it to 12.5% if you wanted. If you do 0.5 as a half. You could also just multiply it by a denominator that would give you a whole number. So if you know that 12.5 times 2 is going to give you 25, then you just have to multiply times 2/2, and that'll give you 25/2. So just like last week when we talked about how an equation, when you need to like move something from one side to the other of the equation, you need to run the operation on both sides to maintain equality. So like if we were going to do 5x minus 5 equals 10, we would add 5 to both sides to maintain the equality. So it would give you 5x equals 15, but it's still, they're both equal to each other. Then you divide by 5 and then x is 3. In this case, the fraction is essentially the equation where the relationship is 12.5% over 1, but if you want to you want the 12.5 to be a numerator or to be a whole number, and you know 12.5 times 2 is 25. You need to add 2 to the bottom as well for equality. And then you end up with this 25/2 again, and then you're basically in the same spot that you were before. Surprise, it's the same answer because it's the same number, just expressed either as a mixed number for percent or a decimal percent. So this part here is kind of where word problems can come in and be, this is how you can solve a word problem, is knowing that there's this relationship where we have the portion, the base, and the rate. And to solve any equation, you need the other unknowns, and you're solving for the one that you don't know. So this is useful in my economics class if you take microeconomics. The equation stuff's useful for microeconomics. But one of the mistakes that students often have when they take microeconomics is that they struggle to rearrange things in their head. So I can teach you how to solve a problem one way but the formula is nice and it's elegant because it allows for you to find things in different ways. So I can teach you how to solve one type of number with the equation, but because of the way it's constructed, you can plug in a bunch of different stuff and get a bunch of different answers. So this is another example of a formula. So a formula in math allows for you to basically use it in a number of different ways to solve different problems. So in this case, what this relationship does is you can rearrange this equation in any way to find the one you don't know. You might know the base and the portion, so then you need to find the rate. You might know the rate and the base, so you need to find the portion. And you might know the base and the rate, or base and the portion and the rate, and then you need to find a base. That's the third one. So if you know portion and rate, you find base. You know portion and base, you find rate. You know rate and base, you find portion. So if you have B and R, then you just multiply them together to find P. So P is equal to B times R. B is equal to P over R. And R is equal to P over B. So those are the three formulas that you just rearrange this equation as it is, and then you can find any of them if you know the other two. So if you know P and B, you can find R. If you know P and R, you can find B. If you know B and R, you can find P. So in this case, I'll redraw this. So if we're solving for portion, we know that we're solving for P, which is B times R. So P is equal to B times R. So if we're solving for portion, we know that we're going to get a base and we're going to get a rate. We just need to figure out what those are. So here's a word problem. Sales of milk chocolate M&Ms are 80% of the total M&Ms sales. Total sales are 400,000. What are the sales of milk chocolate M&Ms? So when they say milk chocolate M&Ms, they mean the type. So there's like peanut butter, mint, dark chocolate, white chocolate peanut, all the weird special flavors. All of the ones that are not milk chocolate equate to 20% of M&M Mars's total sales of M&Ms, and then the other 80% is just the standard, as they used to call them, plain M&Ms, the milk chocolate M&Ms. I was watching an episode of Supermarket Sweep from 1994 the other night, and they were still called plain M&Ms, which I always thought it was strange that they were called plain, because they're so much more than just plain, and they don't taste plain. You think of plain yogurt, it tastes like nothing. Like plain implies that it tasted like milk chocolate. So they were more descriptive. So sales of milk chocolate M&Ms are 80% of M&M's total sales, and M&M's total sales are 400,000. So what are the sales of milk chocolate M&Ms? Well, the rate is the percentage. I guess I should have made that clear. Rate equals percentage. Base equals total. Portion equals what you're trying to find here. So in this case, portion is going to be a dollar value because the base is a dollar value. So if this would have been like how many green M&Ms, we know like 32.73% of all M&Ms are yellow based on our one observation. And we have 6,000 M&Ms. Well, then how many of them are yellow? Well, then it's the same type of problem, but we wouldn't be measuring in dollars, we'd be measuring in yellow M&Ms. Does that make sense? That basically the rate is always, whenever you hear the term rate, inflation rate, APR, annual percentage rate, growth rate, whenever you hear the term rate, you should automatically assume it means percent. Savings rate, inflation rate, all those things. They're all, rate just means percentage. So the rate is always the percentage. The base is going to be the total size of the pizza, the size of the pie, and then the portion is usually what you're trying to find, but sometimes it's not. Maybe you know the other stuff. And so the portion is basically just what slice of pie we're talking about here, and converted to whatever unit that we're measuring. So the portion is going to be unit specific. The base is going to be the total unit, total size of the units, whatever it is, dollars, cents, pizza, ice cream, and then rate is the percentage. So if we know that portion, which is what we're trying to find here, is base times rate, and we know the base is 400,000 here, and we know the rate is 80%, then what is the total? Well, in order for us to find this number, we need to convert the percentage into a decimal. Because as I mentioned before, when you're trying to find the sales price of something, you don't multiply it times 80, you get an astronomically high number. So if we're going to convert percentage into decimal, we always divide by 100. So we go from 80 and move over, and we have 0.80. So here you can plug it into a calculator if you want to, but I believe, if my mental math is correct, this will be 320,000. So you can do this if you would like. The blueprint from the book converts all of this into like how last week where we were like, okay, what's the unknown and what's the variable and what's the process? You can do the same thing here. We know that 80% of the M&Ms are milk chocolate. We know the total number of sales is 400,000. We're trying to figure out how much of the total sales is from, or the dollar value of the proportion of milk chocolate M&M sales. And then in order to find this, we know we're trying to find portion, that's base times rate, so total times the percentage. And so we just plug in 0.8 times 400,000, and we should get 320,000 as our answer. Awesome. So now we can solve for rate. Now we have sales of milk chocolate M&Ms are 320,000. Total M&M sales are 400,000. What is the percentage? So this is the exact same problem as before. It's just that we're showing how we can find, we know what the answer is going to be now. We know it's going to be 80%. But this shows you that by rearranging the equation, we'll get the same answer if we have the other unknowns. So if we have our P over B times R time relationship, we know this is 320. We know this is 400K. And we don't know what that is. And so if we know P equals B times R, we're trying to find R, then that means R is equal to P over B. And we know that R is equal to 320,000 over 400,000. And so that is going to give us 0.8 is equal to R. We want to convert this to a percentage. We multiply times 100, so we get 80%. Because it's asking for percent, not decimal. And then here's the formula again, but hopefully you got it. And then let me guess. We're going to solve base now. So we jump to base. And the problem tells us, okay, sales of peanut and other M&M's chocolate candies. So like the peanut butter, the mint, the English toffee, the dark chocolate, the spooky season M&Ms, all of the ones that aren't plain / milk chocolate equals 20%. So the remaining sales are 320,000. So what are the total sales of all M&Ms? So we know that we're trying to find base. We know originally P equals B times R. So if we're trying to find B, it's P over R. Now this one's a little different because it's giving you the complement. So if you've ever heard of set theory, if you have a whole of something and you know what the opposite is, you can convert it. So we know that not milk chocolate is 0.2, and we don't know what milk chocolate is. We can go 1 minus 0.2 to find the unknown. Whoops. And now we have our unknown. Now we've known this all along because we've had the same problem all along. But if you were to get something like this and it was asking you, if it's asking you about milk chocolate M&Ms and not peanut M&Ms, you need to make sure that you're remembering that you need to convert this percentage that's been given to you to the right base. Because this is actually not the right base. Because if you would have done 320,000 divided by 0.2, you would end up giving 1.6 million, which is not the correct answer. You'd end up getting a number that's 4 times as much as it needs to be. So sometimes word problems can be tricky like this. We got so comfortable being like, oh, it's just going to be obvious. Let me see, like 80% of the total sales are this, and this is 320,000. We can do 320,000 divided by 0.8. We're done. Here they tricked us a little bit and said, okay, this is the percentage of the total of the other M&Ms. So if we know the other M&Ms is 20%, and we know that if you add milk chocolate M&Ms and the other M&Ms and you get 1, then you can just use a complementary relationship here, do 1 minus 0.2, you get the correct rate. So this is the rate we care about. So now that we have the correct rate, now we can plug everything into our handy dandy equation here. And we do B is equal to 320,000 because that's the portion divided by 0.8. That'll give us 400,000 when we plug it into our calculator. And that's dollars. Now, the reason why I knew that was 0.8 is we actually have 100%. Technically, what we had was 100% is equal to 20% plus question mark. We know through the complementary relationship, we get 80%, but then don't forget to convert it back to a decimal, chop this off, move it back, and you get 0.8. That's why I said it's nice to have these nice equations, but sometimes it takes a 1 extra step, because that's where some students will run into problems, is they know the equation, they know what to plug in, but sometimes they aren't plugging in the right number because there's a little bit of a trick to it. So in this one, there was a little bit of a trick where this is the peanut sales, not the other sales that you're actually interested in. Now, if we want to find percent change, again, this is really, if you take macroeconomics with me in the future, percent change is something that we're going to deal with. Well, I guess both classes. If you take macro, we learn about percent change when it comes to inflation rates and changes in growth. If we're measuring elasticity in microeconomics, you use percent change. So percent change is one of the most important things that you can learn in this class that will be applicable to an econ class. But I mean, in accounting, finance, it's also important. Depreciation rates, interest rates, all of that is important. So if you're trying to calculate percent change, all you got to do is plug in this formula. You take the new value, you subtract the original value from it, you divide it by the original value, and then you multiply times 100. So this is going to give you the decimal, and this is what converts it to percent. Because remember, you're always multiplying by 100. You're adding those two decimal places, or that moving that decimal 2 spots to the right. So that's what that 100 is telling you. It's turning into a percentage from a decimal value. If your numerator is positive, so like if new value minus original value is greater than 0, then this equation is telling you that there's growth, that there's a positive change in the whatever you're measuring. If you get a decrease, a negative number, so if you get a negative number, then that means that there's a decrease in your measurement. So let's say you make $50,000 this year, and last year you made $45,000. So if you want to find the percent change in your salary, you take the new salary, subtract the old salary, divide it by your old salary of 45,000, and then multiply that times 100. So 50,000 minus 45,000 is 5,000. That's positive, so that means that your income went up, which I would hope you would know by that point based on your own bills. Divide that by 45,000. Now, these K's cancel out because they're representing thousands. So you're left with 5 over 45. If you're at 5 over 45, you can break this down by 5, and you end up getting 1/9, 1 over 9. So you end up getting 1 over 9 times 100. So you could, if you want to leave this as a fraction, it would be 100 over 9. But if you want to convert this into a proper percentage, then you would have to go 100 divided by 9, 1, 9, 1, 10, 1, 9, 1, 10, and you would be left with 11, 1, 1, 1. You'd be left with 11.11% as your growth. That means your income went up by 11% if you got a $5,000 raise from $45,000 a year to $50,000 a year. So any questions about that? Hi, I'm back. Sorry, my Wi-Fi cut out, so I'm mobile hotspotting right now. But anyways, let me share my screen real quick. So I prefer this formula where it's the new value minus the old value divided by the old value times 100. They're trying to sandwich in this whole, in the book, the portion over the base, and rate implies a percent, as I mentioned before. So this is another word problem where we could find a percent change. So Sheila went to the supermarket, bought a bag of M&Ms. The bag gave its weight as 18.4 ounces, which is 15% more than a regular 1 pound bag. Sheila, who was a careful shopper, wanted to check and see if she was actually getting a 15% increase. So to confirm this, she takes the 18.4 that she got, compares it to 16 ounces because 1 pound is 16 ounces, divides that by the 16 ounces. You get a 2.4 ounce change. These cancel out. 2.4 divided by 16 times 100. So you could get 240 divided by 16 when you multiply this times 100. 240 divided by 16. Gives you 15. Whoops. So you get 15% because this breaks down. If you divide this by 16, you get 15. You divide this by 16, you get 1. And then, so since there was a 15% increase in the net weight over the original 1 pound bag, the weight is actually 115% of the old weight. Because if you did 18.4 divided by 16, you would get 1.15. And then if you have a decrease, so if there's what's known as shrinkflation, have you ever heard of shrinkflation before? Shrinkflation is the situation where they keep the price the same on a product, but because of the fact that the quantity of in the actual bag gets smaller. So even though the price is the same, you're actually paying more because you're getting less. So maybe back in the day it was a 16 ounce bag. Now it's 14.1, then 13, then 12.2. So like you're still paying like 249, but you're getting less when you get that 249. So it's called shrinkflation instead of inflation, where they just give you the same amount, but they jack up the price. They try to do little incremental changes to make it seem like you don't notice it. So in this case, I don't like this. I don't like this whole like 16 minus 12 keeping it positive, because then it implies that you're actually growing. What I would reframe it as 12 minus 16 over 16. This gives you negative 4 over 16. And then you get negative 1/4. Negative 1/4 converts to 0.25, negative 0.25. Convert that to a percentage, it's negative 25%. So the negative sign implies the decrease. And then if you're comparing it to the original, when you do 1 minus 20, or 0.25, you get 0.75. So that means that the new bag is 75% of the old bag. So let's do a textbook problem. We want to convert this from a decimal to a percent. Then all we got to do is move this over to the right. Remember, decimal to percent goes to the right. Percent to decimal goes to the left. So in this case, we should get 600.6% as our answer. We're converting this percent to a decimal. Remember I said percent to decimal. We go to the left. So we get rid of the percent sign. We're left with 119. Go over to the left. We have 1.19 as our answer. Convert the following fraction into a percent to round to the nearest 10th percent as needed. So if we have 7/8 and we want to convert this to a percentage, the first step is to convert it to a decimal. So you get 7/8. 70, you end up with 8, 64, 6, 7, 56, 4, 0, 5. So you're left with 0.875. You want to convert this to a percentage, you got to go to the right 2 spots. So you're left with 87.5%. If we want to convert the following percent to a fraction, then what we need to do is we need to turn this whole number into part of the numerator. So we multiply 31 times 3. That gives us 93 plus 2 is equal to 95. So we get 95/3. And then we need to divide by 100 because we're converting from a percent to a decimal. So percent to decimal, you go back because you're dividing by 100. So we multiply it times 100. We get 95/300. This is divisible by 5. So we get 19/60. And that's what we have here. So we want to solve for the portion. So what we want to find is what is 119% of 128.9. So portion is equal to base times rate. This is the rate. This is the base. So the base says that 100% basically is equal to 128.9. The base is saying we want 119% of that. So if we want 119% of 128.9, remember we need to convert this to a decimal. So we need to drop the percent, move over 2 digits, we get 1.19. Since the base is 128.9, we do 1.19 times 128.9, and then we get 153.39 as our answer. Solve for the base. So remember P equals B times R. So if we're solving for the base, it's P over R. 36 is equal to 0.75% of what number? So notice that this is 0.75%, not 75%. So we need to convert this to a decimal. So we need to go chop that off, move over to the left 2 digits. So we get 0.075 is equal to R. 36 is equal to P. So that's the portion. So P divided by R is 36 over 0.0075. And then when we do that, we get 4,800 as our answer. If we're solving for the rate, again, P equals B times R. 0.09 is actually our portion. Our base is 2.25. So we need to find R. If we're trying to find R, we're going to do P over V. So we end up with 0.09 divided by 2.25 equals R. So when we do 0.09 divided by 2.25, we get 0.04. This is our rate as a decimal, but it said we want a percentage. So we need to turn it to a percentage, go over to the right, 4% is our answer. So does anybody have any questions? Okay. So we will go ahead and take our break.